Hello friends, welcome to Aptdemy. Hope you are doing well with our e-learning platform. Course materials are already available. We have given the question papers. You can solve the question papers. If you have any doubts, please come back to us through interactive sessions. We'll help you in solving the problems what we have given to you. Recently, I have got a request from many of the students to solve a particular problem on coordinate geometry. I'll be dealing with that. This problem was given last year in a very famous competitive exam in India. We'll try to solve it. So please keep on sending such problems. If you have doubts in solving the problems, please give it to us. We will work it out. We will take special classes for you, like this class, and we'll cover these topics, and you can interact and learn more. Okay, and what happens in whatever course materials are there, meticulously go through the materials, solve the problems, and you just gain expertise in solving those problems. So, okay, let us now go straight into the problem. What is that problem? It is actually, you can call it a problem from circle, or it is a geometrical problem. It doesn't fall under anything. Lot of trigonometric concepts are also used in this problem. Algebra is also there, so it's a mixed sort of problem. I cannot call it is a problem from circle or coordinate or trigonometry. Let us see what that problem is. Try to follow the steps, and I hope if you understand the concept behind this problem, then it will help you in tackling similar problems in future. So what is the problem? Let G be a circle of radius r, capital R, and let G1, G2, Gn be n circles of equal radius small r, which are obviously positive numbers. Suppose each n circles G1, G2, Gn touches the circle G externally. Also, for I equal to 1 to n minus 1, the circle Gi touches Gi plus 1 externally, and Gn touches G1. Then which of the following statement is a true? It's an MCQ type problem, and that famous competitive examination, there may be multiple correct answers in a problem. So you should be very careful in each step actually. It is not, you should not be happy if you find a single correct answer. There may be more than one correct answer. There may be no correct answer in your this thing. So you should be very careful. So let us try to roughly sketch geometrically what the problem states. So there is a circle capital G, big G, something like this. So let us choose a color scheme. I think white color will be most suited. So this is a circle G. Okay, so this is a circle G whose radius is capital R. So this is the center of the circle, and this is the radius of the circle. Simple. Now there are n number of circles G1, G2, Gn, which are touching this circle G externally. So roughly I can draw like this. So this is G1, this is G2, this is G3. What is said that all these circles, they have equal radius, which is small r. This is r, this is r, and so on. And it is said the circle Gi touches Gi plus 1. That means G1 touches G2, G2 touches G3, and so on. And finally, Gn touches G1. That means if this is the nth circle, Gn touches G1. So it is a nice geometrical structure. All the circles are like this, one touching another, and all the circles touch each other. In that manner, it continues. Okay, that means all the centers of the circle, they lie on a bigger circle whose radius is r plus smaller. Up to this, there is no doubt. All right. Now let us draw a cleaner, neater diagram, which will be useful for calculation purpose. So the circles look like this. Actually, one touching other, this touching this touching this, and so on. And all are external to this circle, and all are inscribed in a bigger circle, you can say, which is a dotted circle. And the radius of the dotted circle is definitely smaller plus capital. Up to this, no doubt. Okay. Now come to this diagram. So we will use a very important result of trigonometry here. So before that, you just take two adjacent circles. Call this circle GI and call this circle GI plus 1. Okay, this will be third circle, this will be fourth circle. Take two adjacent circles. Take the centers of these circles. This is the center of GI circle, call it A, and this is the center of GI plus 1 circle, call its center to be B. This is center of the big circle. I should not say big, circle G. This is circle G. Its center is C. So I take A, B, C, these 3 points, 3 centers, and take out this figure from this diagram. So you get a circle like this. It is C. This is B. This is A. Okay. Now what is this length RC? RC is actually what? Radius of circle G plus radius of circle GI. But this is smaller, this is capital R. So this distance is R plus R. What is this distance? BC is again R plus R. And since it is R plus R, why? Because the circles, they touch externally. When two circles touch externally, the distance between the centers is always equal to the sum of the radius. You know that? If two circles touch externally, if these are the centers of these two circles, if these circles touch externally, that means they are touching only at one point, then distance between the centers of these two circles is nothing but radius of this circle plus radius of this circle. So if this is C1, this is C2. C1, C2 is actually R plus R. It is your class 10, class 9 knowledge. Okay, so we can write like this. And similarly, GI and GI plus 1, these two circles, they touch externally. So what is the distance between these two circles? Distance between the centers of these two circles? It is definitely R plus R, 2R. So AB is also equal to 2R. No doubt. So this diagram is clear. This is very fundamental. And call this angle theta. Now, let us remove this part. It is not required anymore. Now, what we can guess about theta? What you can guess about theta? See, just for your benefit, let me draw this diagram. A rough diagram. This is 1, this is 2, this is 3, this is 4. This is not a perfect diagram. Just for understanding, let us draw a diagram like this. Okay. Now, how many external circles are there? It is just like a flower-like structure. How many external circles are there? Here there is 1, 2, 3, 4, 5, 6, 7, 8. That means in this case you can say n is 8. 8 number of external circles are there, and this is inside this is circle G, whose radius is R. And these circles all have radius R, smaller. Okay, now complete this diagram. Whatever I have drawn over there. Again, I have reproduced this diagram over here. So I can complete such diagrams for all the circles, adjacent circles. So don't get confused. How many such triangles are there? 1, 2, 3, 4, 5, 6, 7, 8. Undoubtedly, this is one triangle. This is one small triangle. It is a section of pizza, you can say. It's a circle sort of thing. And these are the small triangular shapes. So how many such triangular shapes are there? 8 triangular shapes are there. And all are uniform because these are all same. So what is this angle in this case? So theta, if I call this angle theta, so how many such thetas are there? 8. And 8 theta makes how much angle? 2 pi. Make it, call it 2 pi. 360. So theta is actually 2 pi by 8. 2 pi by 8. Or if had there been n number of circles, I would have said that theta is 2 pi by 8. Had there been 4 such circles, I would have said theta equal to 2 pi by 4. So in general, if there are n external circles, then the angle at this point made at the center is actually 2 pi by 8. Up to this, I hope there is no doubt. Even if you have any doubt, you can write to us through many channels. We can further clarify. Okay, so we have understood that these angular strips, they make angle theta, which is 2 pi by n, at the center of the circle capital G. This is the center of the circle of capital G. Here the angle made theta is equal to 2 pi by n. So up to this, it is pure geometry. 2 pi by n. Now let us, for this such a triangle A, B, C, the dimensions of the triangle, I hope there is no doubt. This is 2R, this is R plus R, this is R plus R. So it is an isosceles triangle. Two sides are equal. Now what is the relation we can derive between R, small r, capital R and theta? For that, we just go back to trigonometric knowledge. I told in the beginning, this problem covers many aspects, many subjects together. So if you just consider a triangle, try to understand. If you just remember this thing, so this is a triangle A, this is a triangle, so let me call this triangle ABC, capital A, B, C. So this side length I call it C, this side length I call it A, this side length I call it B. Okay, and if this angle is theta, don't confuse this theta and this theta, this is a separate issue. Just think it is a separate issue. If this angle is theta, if this length is B, this length is A, this length is C, then do you recall any relationship between A, B, C and theta? If you do not recall, okay, don't bother, let us derive. Drop a perpendicular from A on BC. Call this foot of the perpendicular N. Then what happens? Cn is how much? Cn is B cos theta. Because Cn by AC is cos theta, and AC is B, so Cn is B cos theta. No doubt? Okay. Now what is An? A is B sin theta. Okay. And what is Bn? What is Bn? Bn is actually A, because entire BC is A. So it is A minus B cos theta. This is A minus this much is A minus B cos theta. So value of Bn is known, value of An is known. So I can write from Pythagoras theorem, again class 10 geometry, AB square is equal to AN square plus Bn square. I can write, but AB square is C square because length of AB is C. So C square is AN square plus Bn square, but AN is sine theta. So AN square is B square sine square theta plus this thing Bn. Bn is how much? A minus B cos theta. A minus B cos theta whole square. Up to this, no doubt. So there will be one B square cos square theta to make it square, and there is one B square sin square theta. When they are added, it gives B square. From this square, I get one A square also, and I get minus 2AB cos theta. Okay, so I can write cos theta is equal to A square plus B square minus C square divided by 2AB. So cos theta is A square plus B square minus C square by 2A. This is a famous trigonometric formula. You might not have read, class 11 students, you will consider it shortly. But just I have derived this formula will be useful. In competitive exams, you are given problems where concepts of various subjects are required to solve a particular problem. So here, this will be very useful. Cos theta equal to A square plus B square minus C square by 2A. Now, if I apply this formula in this problem, in the problem of ours, how does it look like? So instead of theta, I write cos theta is how much? 2 pi by n. Is it okay? What is this? Is A, this is B, this is C. So I can write actually R plus R whole square. Let us remove this part. So R plus R whole square plus R plus R whole square minus 2R whole square divided by 2 into R plus R into R plus R, which is actually R plus R whole square. After this, we can readily apply this formula here. No doubt. Okay. Now let us remove this part. This is no longer required. Once you have understood how to derive the formula, you can readily apply the formula in our problem. So let us try to simplify this expression. So what happens in this case? So it is basically 2R plus R whole square minus 4R square. Four square divided by 2R plus R whole square. 2 if you just cancel, then you get R plus R whole square minus 2R square divided by R plus R whole square. So if I divide, I get what? 1 minus 2R square by R plus R whole square. Try to follow. Now, what I can write? Cos theta. You know, I can write cos theta, little trigonometry. This cos theta is, I can write cos square theta by 2 minus sin square theta by 2. You know that? It's very simple formula, you know that. So cos square theta by 2, I can write 1 minus sin square theta by 2. So I can again write it is 1 minus 2 sin square theta by 2. I can write. So what I can write from this cos 2 pi by n is very simple. 1 minus 2 sin square pi by n is this much. 1 minus 2 r square by r plus r whole square. Up to this, no doubt. So what I can write from this? I can write from this simply because this 1 cancels. Then ultimately I can write from this sin pi by n is equal to sin square pi by n is equal to r square by r plus whole square. There is no mistake, I think. 1 cancels, negative sign cancel, 2 cancels, so sin square pi by n is small r square by r plus r whole square. So I can write sin pi by n, apparently sin pi by n is a acute angle pi by n. So I take the positive root r by r plus r. Okay, so cosec pi by n is reciprocal of pi by n, sin pi by n is actually r plus r divided by r. Just reciprocate. I can write, so I can write this is equal to 1 plus r by r. We can write. So what happens? See what happens. So r by r by small r is cosec pi by n minus 1. Okay, so capital R is r multiplied by cosec pi by n minus 1. We can write this formula. Capital R equal to small r cosec pi by n minus 1. This formula I will use in solving this problem. So we have to derive a formula to work out this problem. Capital R equal to small r cosec pi by n minus 1. So let us capital R equal to small r cosec pi by n minus 1. This is the formula. Actually, from this point, we will start solving the problem. Up to this, I hope there is no doubt. Okay. Now, come to the situation A. Let me again write r equal to r cosec pi by n. You recall, though there is no diagram in this, n is the number of external circles. So r is the radius of outer circles, and capital R is the radius of inner circle, which I call G. All right. Now n is what? 4. If n is 4, you just plug in n equal to 4 in this expression. So r is how much? R cosec so now it's a cakewalk for you. Sin pi by 4 is how much? 1 by root 2. So cosec pi by 4 is root 2. So it is r into root 2 minus 1. So r is specifically equal to r times root 2 minus 1. But here it is given r is greater than root 2 minus 1 r. So undoubtedly this is a false statement. When n equal to 4, capital R becomes equal to r times root 2 minus 1. Here it is given r is greater than root 2 minus 1r. So this is a false statement. Okay, next part of the problem. So what is that? N is 5. So just let me remove all these things. So this is the base formula. We are using this formula. Now n equal to 5. N equal to 5, you just, so it becomes r equal to r cosec pi by 5 minus 1. Pi by 5 is how much? 36 degree. You may not recall what is the value of cosec pi by 5 because we generally remember 30 degree, 45 degree, 60 degree, 90 degree, 0 degree. So it is, I don't expect you to remember this formula. What is the value of cosec pi by 5? If you can remember, because it is a standard angle more or less 36 degree, so try to remember sine 36 degree, cos 36 degree, these values. But sine 18 degree, cos 18 degrees. But okay, there is another easy technique to tackle this problem. How little insight in trigonometry is required. How we can take up this problem? Here actually little knowledge of trigonometry I will use. See, if any angle theta is acute, you just try to, if this is theta and this is sine theta, call it x, don't confuse with theta. So call it x. So sine x versus x looks like this. Graph looks like this. This angle is actually pi by 2. So lower the angle, lower is the value of sine x. This concept I will utilize. So lower the angle, lower is the value of sine x. So just consider two angles, pi by 6 and pi by 5. Pi by 5. So which is lower, pi by 6 or pi by 5? Definitely pi by 6 is lower. So pi by 6, if it is pi by 6, it is pi by 5. So sine of pi by 6 must be less than sine of pi by 5 because pi by 6 is lower than it. So I will just use this concept. So when x is an acute angle, sine x is lower the value of x, sine x is lower. Higher the value of x, sine x is higher. But this character changes as soon as x crosses pi by 2. As x increases, sine x decreases. But below 90 degree, as the angle increases, sine x increases. This is a very fundamental key concept. I am keeping this. Now what happens? So sine pi by 5 is greater than, sorry, whatever I got, sine pi by 5 is greater than sine pi by 6. But what is sine pi by 6? Sine 30 degree. Sine 30 degree is half. Is it not? So reciprocal of sine pi by 6. If something is greater than half, then reciprocal of that must be less than 2. So I make this cosec pi by 6. Cosec pi by 6 is less than 2. Okay? So cosec pi by 5 minus 1 is less than 2 minus 1. Cosec pi by 5 minus 1 is less than 1. Okay? Now, if you multiply both, this is an inequation. If you multiply both sides of the inequation by small r is a positive number, no harm in it. So r times cosec pi by 5 minus 1 is less than r. Up to this, no doubt. But what is this? R times cosec pi by 5 minus 1 is capital R. So capital R is less than small r. So as per our calculation, capital R becomes lower than small r. But what is given in the problem? Capital R is bigger than small r. But we have got capital R is less than small r. So this must be a false statement. So trick what we have used here, since we do not know the value of sine pi by 5, we do not know. We know how to calculate, but we do not remember in the exam center. So I used the trick and got the result. Okay, so this is a false statement. Now come to the third point, third problem. Actually, there are four problems in this. And if you solve this problem, you make a good score actually in the exam, because it's a MCQ type with multiple correct answers. And here actually you score good marks if you can solve the problem in iterative. Now, what is, okay, let us remove this part also for the timing. So now n value is 8. N's value is 8. That means pi by 8 is how much? 22.5 degree. 22. Pi by 4 is 45 degree. Half of 45 degree is 22.5 degree. So how do I solve this? N equal to 8. Sorry. N equal to 8 means n equal to 8. Third part is n equal to 8. So it is cosec pi by 8. But cosec 22.5 degree also I do not know readily. We can calculate the value of cosec pi by 8, but let us apply some trick over here. So again, this thing, sin x versus x. So pi by 8 is definitely a smaller value compared to pi by 4. Is it not? So same trick if I apply. So pi by 8 is smaller than pi by 4. So sin pi by 8 must be less than sin pi by 4. But sin pi by 4's value we know. It is 1 by root 2. Standard value. So sin pi by 8 is less than 1 by root 2. And therefore reciprocal if I take, then it becomes greater. Cosec pi by 8 must be then greater than root 2. Cosec pi by 8 is greater than root 2. Then what do I do? Cosec pi by 8 minus 1. Cosec pi by 8 minus 1 must be greater than root 2 minus 1. Okay? And then r times cosec pi by 8 minus 1 must be greater than root 2 minus 1 times r. But what is this? This is this capital R. Small r cosec pi by 8 minus 1 is capital R. So I get capital R is greater than root 2 minus 1 small r. What is statement given in the third? C, capital R is greater than root 2 minus 1 small r. Capital R is greater than root 2 minus 1 small r. Therefore, this must be a true statement. This is true. Statement C is true. Hope it is clear. Okay. Now we are left with another problem. Another last part of the problem. If n equal to 12. If n equal to 12, let us remove this. If n equal to 12, then how much is pi by 12. If you divide 180 degree by 12, it becomes 15 degree. So sine cosec 15 degree you can calculate, and it will be useful if you calculate the value of cosec 15 degree in this problem. So here it is, just replace 8 by 12. So it is n equal to 12. So cosec pi by 12. All right. Now same thing here. I'm not calculating, comparing this with any result. Let us try to find out the cosec pi by 12 value. How do we do that? It is cosec 15 degree. What is the value of cosec 15 degree? So for that, what I do, I calculate the value of sine 15 degree. But sine 15 degree is actually sine 45 degree minus 30 degree. And we know the standard formula sine A minus B is sine A cos B minus cos A sine B. So I write this is sine 45 degree cos 30 degree. It is very familiar, minus cos 45 degree sine 30 degree. Sine 45 is 1 by root 2, cos 30 is root 3 by 2, cos 45 degree is 1 by root 2, and sine 30 is half. So it becomes root 3 minus 1 by 2 root 2. So sine 15 degree becomes root 3 minus 1 by 2 root 2. So cosec 15 degree is how much? Reciprocal of this, it is 2 root 2 divided by root 3 minus 1. So if we rationalize the shorts in the RHS, it becomes how much? You know, it is a very standard technique. You have learned it in class 9 itself. 3 minus 1. So in the denominator I get a 2, in the numerator there is a 2. So I am left with, actually this is 2, not 3. This is 2 root 2. 2 root 2 times root 3 plus 1. So it becomes root 2 multiplied by root 3 plus 1. Okay. So it is root 2 multiplied by root 3 plus 1. So sine 15 degree, cosec 15 degree is root 2 times root 3 plus 1. So I am having this thing. So it is, I can write capital R is equal to small r root 2 times root 3 plus 1 minus 1. Okay. So it is r times root 2 into root 3 plus 1 minus small r. I can write, so take this minus r in the LHS, it becomes r plus r is r root 2 root 3 plus 1. So what I can get? R into root 2 multiplied by root 3 plus 1 is r plus something. So this quantity r, so I can readily write from this root 3 plus 1 is definitely greater than r, because when r is added with small r, I get this. So this quantity is definitely more than r, and this statement is what? R is less than root 2 into root 3 plus 1 multiplied by r. R root 2 root 3 plus 1 is greater than r. So I have got exactly the same result. That means this statement is true. So in this problem, I found A is incorrect, B is incorrect, A is false, B is false, C is correct or true, D is correct or true. It should be the answer. A is false, B is false, C is true, D is true. So this is the technique by which you can solve. And it was said in a very famous, most competitive worldwide exam in India last year, and many students asked me to clarify this problem. So I tried to explain how this problem can be attacked. And you see, in this problem, I cannot call it a problem on coordinate geometry or trigonometric algebra, many mathematical concepts are used here to solve this problem. I hope you have understood and followed the steps. I I think this technique has been useful to you. So thank you very much for your patient listening. Try to understand and follow, and you can watch it repeatedly as many times as you feel subsequently. I think it was useful to you. Thank you very much. What will you?